I'm here.
Good morning. Good afternoon. Do you want to just, we can just read this just to remind everyone that we're going to record the session. And I don't know if you want to just say a word about the use of the notes.
Yeah, so I'm part of a project together with Hakeem Weatherspoon and Stephen Wolf here at Cornell to look at the social impact of farm networking. My background is in human-computer interaction and science studies. And so we are looking at, we're trying to understand better how people are thinking about the potential of these future networking technologies for farms. And I will be taking notes on this meeting together with Sarah Sachs and Jen Liu, two of our project team members. And we will be using this to analyze what possible social implications of FarmBeats could be. And also eventually to develop policy and design recommendations. We won't quote anybody, and we won't use screenshots of anything without asking your permission. I just want to let you know that that's happening.
Thank you, Phoebe. And if anyone does not wish to be recorded, let us know.
Yes, thank you. Me too.
Thank you. And I think Phoebe and her team have also promised to give us the summary as the project wraps up on what their findings have been.
Yeah, we'll definitely be sharing our results. And if there's anybody who's wants to get more detailed interaction about the particular project you're working on, I'm happy to meet with you and talk about those things. If there's things that we can do to help you, we're definitely interested in doing that.
Fantastic, thank you. So we have, welcome everybody. Good morning, good afternoon. Thank you for joining us for the FarmBeats User Community Workshop today. We have two topics that we're going to cover. First of all, Steven Mirsky is going to give us a talk on the work he's doing at the USDA. And then we've invited Ranveer, Zena, and Zena to give us an update on TV Whitespace, what the different options are, and just kind of talk us through some of the considerations. Because I know a number of you that we've been working with have been very interested in TV Whitespace and looking into all the factors that go into making a decision about what to purchase. Okay, so let's get started. Stephen, we'll hand it over to you. Steven Mirsky is a research ecologist at the USDA and has been working with FarmBeats for has it been a couple years now?
Yeah, feels like it's been almost over 2 years now.
Welcome and thank you for joining us.
Thank you. I'm going to just switch to my headset, which I thought I had already done. That doesn't seem to be working. Can you hear me and see my screen?
I can, yes.
Okay, wonderful. So I'm going to give a brief overview of the Precision Sustainable Ag team and some of our workflow, how we organize ourselves and support real-time communication and data acquisition, aggregation analytics, and such, and kind of just give a little bit about our structure and who we are. So, you've gotten a nice deep little dive on some of our technologies historically from Chris and Paula. And so we have a suite of different types of technologies that we're developing in this team. I'm more going to give you an architectural view of us and how we work. And so you'll get a better sense of the kinds of solutions that we're delivering. And then I'll end with just a brief little linkage to some work that we're doing with Microsoft. So this just gives you a sense of the scope and the scale of a lot of the players that we are partnering with. The Precision Sustainable Ag team is up here in the top right corner. I'm just going to turn my headset off because it just keeps trying to work and it's not working. All right, so this in the top right corner here is the Precision Sustainable Ag team. And that team is really compiled of a lot of teams and a lot of different universities.
Can you please mute if I can also try to mute everybody. There we go. Okay. Sorry about that, Stephen.
Can you hear me now?
Yep.
All right, great. So this represents a large consortium of teams, that are, universities, ARS, some private partners, and this doesn't even reflect everybody because we continue to grow, but we have the Precision Sustainable Ag team, which I'll talk about today. They are connected and overlapping with many members that are part of a national herbicide-resistant weed management team called GROW, getting rid of weeds, and a national cover crop breeding team that's developing new germplasm for sustainable agriculture. And so we are this large network. You can even see Microsoft is one of our collaborators in this network. And we have other private on-farm networks that we are collaborating with and other companies as well. And this group continues to grow. At the heart of our effort is coordinated on-station and on-farm research. So on-station experiments.
Steven?
Uh-oh, looks like we may have lost him.
Yeah, can you guys, everyone can hear me and Stacy? I think we might have lost Steven if that's the case.
Yeah, I think we lost Steven.
Yeah, I can hear you guys.
Okay, well, let's see if we can get Steven back. It's just a technical glitchy day. Hopefully he will realize that he's frozen. He's not giving the presentation without realizing. Let me see if I can reach him. Stacy, do you have a way of pinging him by phone?
Let me see. I'll double check.
Thank you. Okay. Well, we've lost his slides now too, so. Well, while we're waiting for Steven, is Hakeem on? I know we have a few summer fellows on. I don't know if I see Hakeem, but I was going to ask Shang and Guar if you guys might be willing to do a presentation on your work at one of our upcoming community meetings. You guys did such an excellent job. So I won't put you on the spot to commit right now, but I'll send an email to Hakeem and see if we can twist your arm.
Sounds good.
There's this farmer who's delayed in getting you information. You should let him know.
Was that Andrew?
Yeah.
When are you guys done with this semester?
That's a good question.
Yeah,
I think somewhere in late December.
Fall break, which is like 2 weeks long, and then school semester starts back up, and we finish December. Well, I know I have to stay here in the dorms until December 21st, but I don't know when the actual school semester ends.
And
Yeah.
well, we'll put it off until January, so you have a breather.
So
All right. Well, we don't.
I tried Steven's cell and it just goes right to voicemail. So I'll send him a note and see if he expects to be able to rejoin.
Okay. Well, in the meantime, we have I know we have Zena and Zerina on. Do we have Ranveer? What we could do is jump over to the TV white space if you guys are ready, and then we can come back.
I'm here, Elizabeth.
Oh, Ranveer, there you are.
Yeah.
All right. Are you okay? We'll just start with the
He's good. Although Steven's back.
Oh, Steven's back. Hey, Steven.
Hello. Can you hear me?
Yes.
Oh man, so much fun. Not sure what happened. My internet and the whole house went down. So,
Well, you recovered nicely.
I don't know where my white space is. That could have fixed that for me.
Right.
Anyway, sorry.
No worries. We were just going to jump to TV white space, but now that you're back, if you want to pick up and share your slides. We can keep going.
You see my screen?
Yep.
All right. So
back.
Anyway, I don't know where I left off. Otherwise, I was just saying that we are coordinated on-farm and on-station research. We are a large on-farm network. That's the heart of what we do. But we also develop solutions that feed into on-station research. And these green circles represent research stations connected to our network, and the orange and the purple dots represent part of our on-farm network, and that has been a growing network over time. So we started just a couple of farms in the East Coast, and somewhere around $20 million later, we are now over 265 farms across the eastern half of the US and growing. So we've been successfully expanding this farmer network for many, many years now through different capacity grants and you know, public-private partnerships. And so going into next year, I think we should be somewhere around 260 farm fields across the eastern half of the US. So even some of these images are dated. And a big part of what we do is IoT everywhere, right? I mean, that's what makes on-farm research possible, right? Is you can capture massive amounts of information across, you know, large, you know, swaths of different climate and soil regimes for low cost, and get lots and lots of information about those systems. So we are really focused around integration of IoT all across our on-farm networks. And that is to support, you know, this real-time data acquisition, aggregation, analytics, and visualization. And so we are developing all of the cyber infrastructure around these different steps. And we also collaborate with FarmBeats around some of the ways that they achieve those goals. And if there's a solution there that works well within our network, we're certainly exploring that space. Right now, the network isn't on FarmBeats, but we are looking at FarmBeat tools and testing them as part of what I would call the alpha testing phase, which I'll describe in a second. We also provide data visualization systems for our growers. This is one of our outdated visuals. We are kind of updating some of our visuals, but here's an example of a farmer can type in their name. They get outputs about the performance of a cover crop on their field. They get information of how that corresponds to other farmers in their state, get information about how much nitrogen that might be producing, and more. But that just gives you a little sense of it. I'm just going to check in. Can everybody still hear me? All right, good. I don't want to like keep talking to myself like I did before. All right, and so everything is going towards decision support, recommendation systems. Now, some of it is for the what if questions, right? Like you improve some conservation strategy by 10% in a region, and you improve the performance of that practice by 10%. How is that driving nutrient loading in the Chesapeake Bay or the Gulf of Mexico? Or how is that affecting greenhouse gas flux or carbon sequestration? We're building the tools and the models to answer those kinds of questions across our networks, and more importantly, to be able to do that at scale. We're breaking down the data silos that exist across research networks. We're probably the largest coordinated research network, I think, that I know of. But, you know, we're over 120 plus scientists across the US that are coordinating their data acquisition and analysis, which allows us to break down the dissatisfaction of like 2-year and 3-year master's and PhD projects where the data does not connect, and it could be done in the wettest year in recorded history, the driest year in recorded history, which is seemingly the pattern every year now. And so how do you make sense of this information if your data is not connected? You basically say, well, I couldn't make sense of my treatment effects because they weren't consistent from year 1 to year 2. But if we could put that data together across many states and many soils and many management regimes, we can start to build insights. And that's a core focus of ours, as well as the technology transfer either to the typical technology transfer pathways like NRCS, county agents, private consultants, or directly to farmers. And we also want our tools and data to be in the hands of policymakers. So as they're providing cost share or crop insurance or what have you, that they have our data, you know, informing those recommendation systems. And so our data and models are expert-based, empirical and process-based, and hybrid approaches, machine learning and process-based and empirical. So when part of the way we standardize data, and that's big, right? To be able to make data machine readable and usable across coordinated networks, you need to have, you know, standards. And so for us, that we have a 3-phase approach. If you're an early protocol, which a lot of things are, right? A lot of stuff is not refined, it's not a mature protocol, it varies, or you need to make some adjustments on the fly. Those kinds of approaches are not really ready for a fully automated database system or an automated web, data acquisition systems. That really needs to have be flexible and nimble. And so we use products for that support that nimble stage. But then as something matures and it really becomes a protocol that is standardized across the network, which is really only things that enter our on-farm network, those are fully automated data acquisition and aggregation systems. And the downstream flow of that would be full automation of analysis and visualization. And much of that is happening at various different stages across our different methods and metrics. And this is powered by well-structured databases, right? We create organized databases that allow us to take diverse data streams from our web apps to point sensors, to yield monitors on tractors, to destructive samples or equipment mounted or satellite imagery. All of this aggregated into our and structured in our databases, what facilitates building the insights needed across this complex network. And so we look at technology entering this network also in a three-phase approach. There's the alpha, beta, and then available to all users. So alpha testing is like what we're doing with FarmBeats, right? Myself or Chris are exploring a given technology. We are working out the kinks. We're seeing how well it fits for our solution base and needs. And so if this is something that shows promise, we then roll it out to the beta testing phase. Beta testing phase is other experts in our network who are advanced technology users, but have not been part of alpha testing phase. They then, explore this technology and solution, really beat it down, work out, the bugs with us. And that once that becomes really rigorous and robust, that's when it's rolled out to all users. And this is a really critical concept, we think, because scientists can easily get fatigue in technology, just like farmers can. We get fatigued in the amount of software applications, the amount of tools that are out there, the amount of types of ways to collect data. And so you're going to quickly lose scientists if this is not plug and play for them, right? A lot of our scientists want to focus on their science and they don't want to focus on all these different technologies. And if we can't make it work and work consistently for them, then it really isn't well adopted. And so that's why we make this technology, life cycle as an integral to how we work across the network. So now I'm going to show you just some nice little tools and online solutions that support the kinds of things that we're doing. So I'm going to switch here into this. This is our intranet portal. We find this as essential to coordinating both communication and science data acquisition across the network. So everybody in our team can go to an intranet portal and access everything that's going on. They can see our personnel organization chart. They can see who are the team leaders and what their roles are. They can get access to the staff and know what the staff does. They can see what the different team leads are doing and how they fit into the different programs and get the information they need from those team leads. We have information about annual meetings. We have information about the project overview here, as you can see. We have all of our protocols are embedded in here, and so someone can go into a protocol and get access to all of our different workflows. As well as we even have publication documents that guide everybody in the network around how we use data, how we share data, and how it gets used for publication purposes, as well as calendars. And there's other tools that are in here that I'm going to highlight now. So this tool can take you, for example, to our tech dashboard. We've generated our own tech dashboard to help our technicians and the leaders of any one type of technology measurement, like our water sensor network, right? We have what we call a data shepherd for the water sensor. That person is responsible making sure that all the technicians across the network are doing their jobs, that the data is entering the system, that if there are problems in the data, that we have a way to check on that. So for example, you could go to our all data. You could go, let's go to water sensors. So here, for example, in 2020, these are a lot of the farms that are embedded in our network. And so you can go to one of these farms and a data shepherd or a given technician can go and see, is the technology working before they leave the field. They can see what the voltages are. They can look at if they're reading soil moisture readings. They can, when they get back into their office, they can zoom in on any one data point and get a sense for, is there a problem in the data? They can look at the different sensors. They can isolate sensors and just look at how those are performing. So this is not just making sure that we're collecting data, but it's also a way to embed quality controls into our network. And so there's a lot of other features of this tech dashboard that I'm not going to go into now, but another, for example, feature of this is like our site enrollment, right? When a new farmer enters the network, we have a mechanism to enroll them, and that triggers our databases on the kinds of data that we're collecting on these farms and how they're going to access information. So we built in a lot of these different products on our tech dashboard to serve the network and to standardize data acquisition as well as quality control. We also have links to like our repositories. So here we're very active on GitHub. So for example, if you go into our Crown DB, we have a wiki. You can see that we have a very well documented and fleshed out, of all of our. Oh, sorry. Let's go to this. You can see we have our schemas built out, all of the structure, all of this is accessible to anyone in the network. So when you join the team, you know where you fit, how data is being used in the network, how our databases are structured, and then how you can access and build onto this. And so it's really important for all the folks across the network. Then we also have ways to automate, some of our different data collections. So here's just a really simple one. We have an automated map. So like when you join the network, this is why we hate our live demos, right?
It wouldn't be a live demo if you didn't stop for a bit.
Yeah. So, this is just a simple tool that populates where farmers, when they get enrolled in the network, where they show up. This is an older version, so it's not the most up to date. We got probably another 50 or 70 farms in this network, but this is constantly updating where farmers are in the network. So we not only see that they are present, we can constantly keep track of them, but we can do simple things that are pretty cool, like we can determine what soil types they are. So we can say on a soil textural triangle, are we populating the full response surface of all the types of soils that we want to capture, so we are correctly capturing the interactions between climate, soil, and management. And if we don't have farms that are capturing all of the different types of soil texture that's out there, let's make sure we populate our farmer network with farms on those types of soil types. So just ways that we automate. We also automate analysis and other kinds of approaches, but I thought these are cute little ways to highlight some of the workflow. So with that, in closing, all of this facilitates AI applications in agriculture. And so by standardizing and scaling and coordinating our AI developers with our users, we can create those kinds of synergies, and we can link up technologies across different scales as well. So here, for example, you're looking at point sensors. These are measuring soil moisture. This is really expensive, even though we've driven down costs by developing open source data acquisition systems. You still can't get around the cost of a sensor. And so this is really good at getting point measures, but it doesn't scale well. So we're also developing technologies that integrate larger scales of crop stress through different AI, machine vision and learning applications. And then that can be linked up with satellite imagery to further scale. The same that you see above here is that we're doing destructive samples with plants on the ground. We're linking that up to technology that we sense across these fields to type of imagery that we can use. And all of that allows us to say, okay, we know that the resolution of satellite imagery is not as good, but it's covers a lot more land area. But if we can't effectively monitor, the kind of resolution we need, for example, for identifying two species, that's not going to work for us. Certain technology can differentiate species, certain technology can't. Certain is good enough for estimating water infiltration and storage or biomass or weed dynamics in a field. And so part of what our network does is look at these types of scaling issues and try to optimize what we can sense with any one type of technology. So for example, right now with Microsoft, we are taking Venus imagery, which is a high resolution satellite, and we are using that satellite imagery to link to our destructive biomass samples of cover crops in our fields at the Beltsville location. We have farms all across Beltsville, my research farm, where we are collecting biomass samples in large areas that we can link to this satellite imagery. We are also linking that to this forage sensor box, but I will talk less about that right now. So then we work with Microsoft, where they're developing AI applications that improves the ability to estimate of these cover crops in a field. And so what I mean by that is, like, satellite imagery historically has capped out at being able to estimate biomass at maybe 1,500, 1,800 kilograms per hectare of biomass. We can't estimate more than that because NDVI saturates and it's just giving you an estimate of cover. And so once you get above a certain point, you really can't use it to indicate biomass. But this type of technology, like these forage sensor boxes, this is integrating LiDAR with sensors and NDVI, and so it's enabling us to estimate much wider ranges of biomass up into the 6,000 to 8,000 range. Well, what we're doing with FarmBeats right now is they're using machine learning algorithms coupled with some other data and our empirical data from our farm to try to improve the estimation range of what we can do with satellite imagery. So they're aggregating and linking our data with satellite imagery. We're developing models as a proof of concept at our site, and then part of what we're doing across estimations of their models across our national network and seeing how well that estimates up to biomass values that we've measured destructively. So I know that was a bit of a fire hose to give you a sense of the scope and the scale of the work we do, and then kind of try to narrow it down to a specific connection with FarmBeats. I hope that I've illustrated the kind of work that we do and what we're doing with FarmBeats.
Well, that's great. Thank you so much. That was a great presentation. So I'd like to open it up for questions for Steven. Guar.
I have a question, yeah. So great presentation, Steven. We've talked before, and to see it in action is finally pretty cool. You mentioned that you're using a SQL-like database, and I was wondering, because with SQL, you usually have to define the schema ahead of time. So how do you adapt to like the database schema as new players come into your network?
So how are we adapting our databases as new folks come into the network?
Yeah, so like as they come in with new data types that they have to give you guys, because I don't know, maybe there's a way you define the database that's accommodates new players coming in.
So I don't think Chris is on the line. If he was on the line, he'd be able to answer that better because that's his job. He's our database guy. But anyway, the main thing here is that, as I mentioned, nothing is really put into these structured databases until it becomes a mature protocol, right? So we don't have like protocols that are changing a lot that are part of our database system, right? That's part of phase one protocols. Phase one protocols is immature protocols. That's where we're using like products like Google Sheets or Airtables and products that we can have nimble and make adjustments rapidly. But as a protocol matures, then it becomes part of the database. Now, part of structuring the database is this new component of our tech dashboard, which is the enrollment site. So when you're enrolling farmers in the enrollment site, that is the mechanism in which a farmer enrolls into a database, right? They're not, I mean, the farmer's not doing the enrollment, the site managers and the tech experts are. But so when a researcher identifies 3 new farmers in the network, that researcher is going to ping, Sarah Seahaver or Brian Davis, our database and data engineers, and say, here's new farmers to the network. And they're like, yes, here's our data enrollment site. This is how you use the data enrollment site. And the act of walking through the data enrollment site brings that farmer into the database and that network. And so then it automatically, and that's part of how we automate assigning identifiers to their water sensors, to their destructive samples, right? That all has QR codes that automate and feed into our databases. So anything that goes into our database is now feeding in through the enrollment site And that is how we kind of structure adding folks to the network.
Gotcha.
Great.
Thanks.
Thank you. Shang, you have your hand up?
Yeah, I do. So just to understand this clearly, so what, Steve, what you guys are doing is you're kind of aggregating data from farmers, universities, companies, and then making that available to those in your network. Is that correct?
It's a bit more than that, just because data sharing and who has access to data, we have a lot of layers of rules around that. But yes, generally, the general statement is true.
Gotcha. And to follow up on that, what's the difference between you guys and, like, for example, on your slides you had Ag Analytics, and I believe Ag Analytics does this similar thing, but more of in a business way to, I think, make money. Is there like a maybe separation, and also like why would they want to share their data with you guys?
Yeah, good question. So we have a contract with Ag Analytics, right? So historically, when we were collecting yield data, and I know this sounds crazy, but we were out there taking hand yields. We were hand harvesting yield data in our strips, right? So in our on-farm sites, we were hand harvesting yield data. We were trying to link it up to combines, but there's a lot of problems with getting the good combine data. And so historically, we were collecting it by hand just to make sure we got the data. Right? But now we have a partnership with Ag Analytics. And so they are providing a pipeline to those combine data, right? So they have contracts with all of these different companies like, John Deere that have yield monitors in those combines. And so now we're getting access to that yield data in our study strips on these farms and porting that into our databases. And so that's an arrangement that we have, I think, at Ag Analytics. They're wanting to service up other data as well, right? They do a lot with satellite imagery and more. So we're continuing to explore that partnership with them, but that is the immediate partnership with them, is serving us up yield data.
Gotcha. Thank you.
All right. I think we could take one quick question, if there's one more question.
Vikram wanted to ask a question, but he wasn't able to raise his hand. So Vikram, did you have a question for Steven?
Sure, thanks. Yeah, I'll try and keep this brief. I enjoyed the talk a lot, Steven. It's a very impressive network. I was wondering how you manage all of the data that you seem to be collecting, and specifically, do you do any kind of edge processing on that data? So are you running any kind of edge analytics, edge machine learning, or computer vision algorithms on the data and only saving process data, or are you saving all of the raw video data back to the cloud in the projects you have?
That's a great question. I'll plan to fill in any of the blanks, but I don't expect there to be any blanks. Our expert is on the line right here, Paula, so I'll let her field that question.
Thank you, Steven. So we are using both. We are using cloud computing and edge computing. In the camera, in the PhenoCam, we are taking images and analyzing the images inside of the device. So we are using edge computing there. But for another kind of projects that we have also integrated with FarmBeats, like with 3D and more things, we are using video and using FarmBeats to organize the data, to put the metadata. And after that, we can use a server to process this information. This is our first.
Got it. Okay.
The only thing I would add to that is just that we are using tools that both serve the farmer and serve the researcher, right? And so some of the tools is just to make sampling for the researcher easier, right? Like, so we know that it's hard for folks to take weed biomass, and not everybody's a weed scientist. So Paula, for example, is developing an application with GoPro technology where she can take videos across a transect in the field and convert that into a weed biomass estimate in a field. So that would be an example of a tool for a researcher that then feeds into our database that could subsequently become models and tools that feed into solutions for the grower. That's different than some of the analysis and data visualization systems that feed right into the hands of the farmer.
Sure. Thanks. Yeah, I appreciate it.
All right. Thank you, Steven and Paula. That was a great presentation and great live demo. Thank you very much. All right. So we'll move to our next agenda item, which is TV Whitespace, and I'll turn it over to Ranveer and Zena and Zarina, who are on to give us an update on TV Whitespace and an overview of the options.
Yeah, hello everyone, and great to see. So Steven, thank you for the presentation. It was awesome, and it's been a great partnership so far, and looking forward to continuing that partnership. And today I just wanted to cover a few things. One is also give an update to the product of FarmBeats, where that's headed, what's the latest in that direction, cover a little bit about the partnerships, and then talk about the TV Whitespaces. So on the FarmBeats product front, as you know, we had announced that product last year. Currently, what we are doing is building the next generation of that, something that's based on a PaaS and something that can scale even more. So that's something which we are working on. And of course, a lot of that work is in collaboration with the partners that we are working with, Land O'Lakes, and you already heard partnership announcements with some of the other companies as well, including PepsiCo and Corteva most recently. So one of the things that we are looking at to engage with you is also thinking about, especially for universities, is as we take the way we are engaging with FarmBeats right now is it's a product, you download it and you build things on top. One of the other ideas that we've been floating around is whether we can take components of FarmBeats and make it available to academia as limited open source, where you could then play with it, modify it, do things on your own. So this is something where we would love to have a discussion with you about things that we are building that if we put in open source or limited open source, or maybe even open source in some cases, how could you use it? What would be the pros and cons? What are the kind of things that you could build on it? Is something we would love to hear, because we want to enable, if we want more collaboration, more building of things on top, would love to get your thoughts and insights into that. And this could be anything from AI models to even some of the data processing components to the databases to sensor stuff. Already the sensor part is something which we've made available to universities, but even the other components, any part you think would help is something we'd love to hear from you and see things that we could do together. So that was one thing I wanted to discuss, because there's no point, there is no point replicating from your end things that we might have done. We also don't want you to feel constrained in your research with what we have done. We want you to accomplish everything that you can do, building on top of things that we've already built. So that is one of the things I wanted to get feedback on from the community. Maybe we'll, this is the first time we're mentioning this at this forum, but maybe in a subsequent call, would love to have a short discussion on this. The other thing that we are doing with, of course, we wanted to talk about was TV Whitespaces. So an interesting development that happened a few weeks back is the FCC passed new regulations about TV Whitespaces. So this is, we've been working with the FCC. Some of you have access to our narrowband TV Whitespaces radios. We've given it to the FCC. We've been working closely with them. And most recently, they made 3 key changes to the TV Whitespace rules, which make them even more useful for rural broadband. First, they are allowing, they increase the transmit power levels. So this is increasing it from, until now it was 4 watts EIRP to now it is, Zena can correct me here, but I think it's 10 watts EIRP in remote areas outside the main cities. The second thing they're allowing us to mount the antenna further high up. So right now there was a limit of I think 30 meters or something like that. It's even higher. So based on the math that we did after that, until now when we talk of TV Whitespaces, we would have told you that you can get up to 5 miles of coverage, 5 to 10 miles of coverage. Now with this new regulations, you're talking of 20 plus miles, like higher power, higher antenna at a higher altitude, which could mean that you could get much longer coverage, which I think is really awesome for the remote areas. If you're looking to provide connectivity, this could be a great offering. And the third thing that the FCC did, in addition to high power and increased antenna height, is they are allowing the use of IoT radios in TV Whitespaces. So this is so until now, before this ruling, the FCC required that you have to use the entire channel. That was a regulation for 6 megahertz channel. IoT radios are smaller, 100 kilohertz, 200 kilohertz. So now the FCC is allowing narrowband communication in the TV whitespace channels, which we believe we were super excited that this is something which started in research with FarmBeats. We started talking to the FCC, and now we have nationwide regulations enabling the use of these IoT radios in the spectrum. We believe this could be a breakthrough for agriculture and remote IoT applications. This could be forestry, this could be even cases like mining and construction. But Andrew, for example, who's on the call, he's been using this extensively in his farm. He's tested it and getting over 15 miles of coverage. And now we'd love to start working with all of you to see how you could use these radios and the things that we could build on top of these TV whitespace IoT radios. So those are some of the latest developments that have happened on the TV whitespaces front. But if there are any questions, I can answer them. Otherwise, would love Zena first to talk and then Zena.
Ranveer, can I ask a quick question?
Yeah, Hakeem.
Yeah, so we're in the process of. Can you hear me okay?
Yeah.
There's some background.
Yeah, so we're in a process of ordering some the TV white space, I guess the broadband antennas, and
right.
Here at Cornell we'll set it up between the Cornell orchard and either a barn or the vet school. And that'll be on a pole. Well, the IoT TV white space mobile. Can you plug it into a Raspberry Pi, or does it have to go on a little pole, or how's it physically?
So the broadband radios, they are self-contained. That is, all you have to do is you have to connect them to a router. So you can think of that as they connect the last mile. You have two TV whitespace radios. I'm talking about the broadband radios. And then you connect it via Ethernet to, like, they have an IP address, right? So it's a router, you fix the routing tables, and that's how all the data is communicated. For the IoT radios, we have them connected to a Raspberry Pi kind of a device, where that would be the relay. That then, because TV whitespace IoT radios are just a layer 2 communication. Space broadband radios provide layer 3. Yeah, Vikram, I had to mute you. If you could unmute and sorry about that.
Yeah, I forgot I was muted. Yeah, so just a quick question. So do you know when the new more high capacity TV whitespace radios will be available for people to use, especially if you want to do something here on the South Farms just across a few miles or even less than that?
Right.
Do you know when that might become available?
So there's some radios that are available. There's one radio from Redline, I think, Radwin. Zena might have the details on this. So there is one of them that's available. The other thing we can do right away is the total allowed power includes the antenna gain. So what you can do is even if the radio itself is not as high power, you can get more power using higher gain antennas. So now that combination of that radio with the higher gain antenna is now possible with the given regulations.
Yeah.
Okay. I'll follow up. I have some more technical questions, but I think that it's easy to follow up with.
Yeah, would love to chat about this, Vikram.
Yeah, sure.
So Ranveer, would you Radwin had a new radio they're going to release. I think maybe I have included it on my presentation. So Ranveer, can I present my screen?
Yeah, you can present. You can present your screen. And Paula, you had a question. I can answer that.
Yes, I have a question. We are working right now and we are trying to set up the TV whitespaces narrowband in the stress camp. So my question is, what is the differences in between? We can see differences in between the hardware per se or just in the firmware?
In the
IoT radios.
In the IoT with the broadband radios, it's a completely different hardware. Broadband is much more power consuming. Narrowband is much more very power efficient. While the broadband would consume, say, tens of watts, this consumes milliwatts, tens of milliwatts. So that's the key difference between, and now, so Paula, I don't know if your question was between broadband and narrowband, or narrowband now and after the regulations, what we expect. So for the latter, if the question was, and thanks so much for trying this out, and as we are working with you on setting it up with your sensors. For post regulations, we expect it would be right now we are going to be starting the certification process of the radios. And once they are certified, we expect it's going to be a firmware upgrade, which will allow you to start using it.
Okay, perfect. Thank you.
Based on the latest regulations, because we don't have all the latest regulations supported yet. So Tushar on the call is the one who's building all of that support for the regulations.
Thank you.
Yeah, Zena, you could.
Sure. Thank you. Thank you, Ranveer. Well, thank you so much for inviting me to your community call. I have here a few slides, and I might go a little bit faster on some of the slides, but I promise I will share the slide to the community at the end of our meeting. So I just want to first kind of lay some foundation, especially when we think of building a network. There are two slides which I would like you kind of look into quickly. So any type of deployment, whether it is a broadband deployment or an IoT, the way we see and we collaborate with our FarmBeats team here in the Airband team is we kind of look into what are the use cases we're trying to do here and what is the coverage and the capacity requirements. So the notion is every network is hybrid, but to select any technology, we have to have clarity on the use case, coverage, and capacity requirements. And based on that, we can provide you some inputs, what technology that you can look into for your deployment. And most importantly, any service provider or internet service provider or any ISP or anyone who wants to build a network, it's good to have that view of what the architecture looks like. So when we are talking about TV white space, for example, specifically, we are talking about the access part of the network, right? So especially in projects with the universities, I think we have had some challenge in the past, especially with IP protocol and privacy related things on the backhaul and the core side of the network. But when we support you, when we provide support, we are purely kind of providing information on the access side of the network on the TVWS space. We can help on the architecture side, on the backhaul, but it's part of the responsibility of the university IT team to do that. Obviously, I think one way or another you have come across about TV white space, but kind of repeating what you have heard in the past, basically the TV white space leverages this unused TV channels. In US, for example, a single unused channel is about 6 megahertz. And we have a lot of those channels which are unused. And everyone who's not a broadcaster using it is in unlicensed basis, which means we are a secondary user of the spectrum. We don't pay for that frequency specifically because it's not allocated for us. Since we are secondary users, we need to have a 30 step that we follow before we build this network. And as part of that, secondary user, the significant reduction on not paying for the spectrum brings also few steps that we need to follow. And other than that, as Ranveer mentioned earlier, these radios are purely layer to bridge. Basically, they are transport networks that are easy to configure and deploy. Now, looking into the steps, which I think is a key specifically, is there is a central database that maintains all the available channels in US. So before you build a network, it is important to look at that if there are available channels and power limits in your area. So for that, we use a central database, as I told you. So when you get a TV white space radio and when you turn on the radio, the radio makes a query to a central database to see how many of those channels are available and what's the allowed power limits. Once the radio gets those information from the database, it's the time the radio to transmit a beacon signal to the client radio. And then the client radio will be able to communicate with the base station. And I cannot emphasize enough, this is a key step to check the availability and then do a spectrum scan. We trust the database for channel availability, but also we have to verify it by doing spectrum scan. And as I work with most of you, there are different approaches we can use to do spectrum scan, including using an expensive spectrum analyzer or maybe a cheaper version of spectrum analyzer and using with our laptop. So it is really key to have clarity on this step and building TV white space network. Now, from hardware vendor point of view, there are some who are good players in the ecosystem, and you see these names. Maybe I've seen these names in the past too. But I would like to say that we are working with all of these hardware vendors, and you see a timeline. As time goes, there are different mature radios that's coming out. In fact, by the end of this month, We had a little bit of delay because of COVID, but by the end of this month, we are launching now a very high capacity Radwin TV white space radio, which can do up to 300 megabits per second on the base station side and 150 megabits per second on the client side. And we're expecting in the new year to have an ASIC chip. It is important to remind everyone here that all these radios, these vendors, these are proprietary radios today, which means you have to use both the base station and the client from a single vendor. The secret sauce inside the radios is not something which is a standard, but we are expecting the ASIC radio to follow and have a standard, which is really good and also helps to drive the cost. Now, to show you a little bit about this new radio that I mentioned earlier, this is a Radwin radio. If this is the first time hearing the word Radwin, this is a vendor who have more than 3 million radios worldwide deployed in other technologies, point to multi-point technologies, with partnership with Microsoft. Now they're launching their TV white space radio and they call it Outland, Radwin Outland. And this radio can do up to 300 megabits per second. So you can put order today for the radio, but you will be able to get it, I think mid of next month will be when the shipping started. So this is one of the new vendors. But even today, we have different vendors who already have their radios out there. For example, 6 Harmonics radio has a higher throughput capacity. It can do about 100 megabits per second. So depending on your capacity need, you can use different vendors for your deployment. We have in the past deployed Adaptrum radios, which has a different type of capacity and also different types of channel bonding for the different type of capacity and coverage needs that we needed. So all these vendors have different unique characteristics and features, but at the end of the day, they all leverage the unlicensed band and they all provide a broadband speed. And one of the things you mentioned, especially with the change in FCC regulation, the other radio, which is a Microsoft radio, is the IoT radio. This is a different type of schema and different type of application with a lower and narrow bandwidths and a lower throughput with a long range communication. And this is primarily targeted for telemetry application. So this is kind of what the hardware ecosystem looks like. And we closely work with all vendors. And this is also a Microsoft radio. So we can help you provide this information. But I think probably one last slide is to show you what the price range is. Of course, price is also a factor of volume, but just a high level, this is today what these radios are selling. And if you wanted to buy these radios directly, you might need to get a quote from these vendors. I think for this call, what I would like to kind of summarize is it is important to identify your use case because that helps you to determine whether it's a broadband or an IoT TV white space that you're looking for. And also it's important to go through the steps properly so that you don't have disappointment at the end of the day. So your network build out need to be as smooth as possible. So checking the database, checking the spectrum are key. And on top of that, you can even have different sessions with database vendors and also hardware vendors, which we can facilitate in our side on the Airband team. Here, I guess I probably use 8 minutes. If you have questions, I'm happy to answer.
And I know we've covered a lot of information today. If you don't have questions immediately, but think of something you want to ask later, of course, you can ask them on the Teams channel, or you can contact Zena or myself or Zena directly. And I know we also wanted to let Zena give a quick update on narrowband, but I don't know, do we have time for that, or would we rather do questions before we wrap it up for today?
Yeah, feel free if you have any questions to send us an email too. So that's another option.
Yeah, and I'm also happy to schedule follow-up calls if anyone wants to get more details about the narrowband radios since we're limited on time.
And I think it's a really important topic that we definitely do want to cover. And just as a reminder, our next community meeting is scheduled it's a week early again in December because of the holidays. So the meeting is scheduled on December 17th. It's at the same time. And if you've noticed in the chat, Andrew Nelson is expecting to be able to give us an update on some of the work that he's doing on his farm. And maybe we can also invite Zena back to talk specifically about narrowband and just some of the differences between the narrowband, the broadband technology, and how you can get your hands on some of those narrowband radios, because as Zena was saying, you can certainly order the broadband radios, but it's not so easy to get your hands on some of the narrowband radios right now. So I think those would both be good topics to cover at next month's meeting.
I think that sounds great. Given that we're at 3 minutes, Stacy, let's put, Zena, if you're open, we could put narrowband on the agenda for next time.
Yeah, that sounds great.
I think that'd be great. All right, any questions for the about TV white space? Anyone has at this time?
I might just want to add one point from what Ranveer mentioned earlier, and the power limit is correct, Ranveer. Now the new power limit is about 10 watts allowed by FCC, which is double what was, more than double actually what was allowed before. So it's a great improvement from FCC.
Excellent. All right. So we can.
Sorry, just a very quick question to Zena. So, sorry about that. So the new 300 megabits per second hardware you said is appearing at the end of the month. Does that reflect the new FCC rules, or is that before the FCC change? So it'll become even better once the new rules apply.
So Radwin radio uses 25 dBm on the radio and 13 dBi, which is about 37 dBm. I think max if you don't have any losses, which ranges from 35 to 37. But the new cloud power is even much higher, so you can even do more if you have a high gain antenna.
Okay, so it'll be even more powerful. Great. Okay, thanks.
Yep.
All right, Zena, thank you for the great presentation, and thank you, Ranveer, for all the updates. And we'll also flag the topic of open source FarmBeats components for maybe for our next community meeting for a discussion. So that's great. Like Stacy said, our next meeting is on December the 17th. I know it's getting close to the holidays, but I hope you can all make it. And I think, Stacy, any other updates?
I don't have any other updates. Another topic I'd like to make sure we cover at a future meeting is we've got new FarmBeats for Students kits that are getting ready to roll out early next year. So I'd like to make sure that everyone gets a chance to take a look at those and see what we have planned. They'll be a great component to university level education, I think either with hackathons or perhaps in a lab. And so I want to give you guys a look at those. We may not have time in December. We're already looking pretty full. So maybe we'll plan on taking a look at those in January.
Sounds great. All right. Well, thank you very much, everyone, for joining us, and for all the presenters. Thank you so much for taking the time.